Alright guys, so part 2 of our lecture. So, similar to the previous question, we're not dealing with light waves, we're actually dealing with sound waves. And they travel at approximately 330 meters per second. So let's say that, just for the sake of practice, we are going to use the same formula as the one that we talked about with light, with the waves. So, I'm going to identify my knowns and unknowns in the second way that you can do it. So if you have a problem like this printed out, what you could do is actually just write out like, okay, well I know that 330 meters per second, I'm going to treat that as my C, calculate the frequency that is that symbol, the nu, and then this describes the wavelength, the 2.5 meters long. So I've identified my knowns and unknowns, and I'm going to write out my formula based on what I have in my problem. So I am trying to solve for frequency. I'm going to divide both sides by the wavelength. And now I'm going to plug in my numbers. 330 meters per second divided by 2.5 meters. I'm trying to find my frequency. I do my math. I end up with 132. 1 over seconds, which is going to be hertz. So how many sig figs? I have 2 here. I have 2 here. So this will be 130 hertz. Microwave ovens emit microwave energy with a wavelength of 12.9 centimeters. What is the energy of exactly one photon of this microwave radiation? So a photon is actually a particle that represents a quantum of light or some form of electromagnetic radiation. That's what a photon is. That's the official definition. So in terms of what we're doing, we are trying to figure out what the energy is. So energy is capital E. That's the symbol for it. And I'm trying to find wavelength. Wavelength is actually, well, I'm trying to find the energy. The wavelength is here. That's lambda. That is 12.9 centimeters. However, we need to convert this to meters for our problem solving to work. So 12.9 centimeters. So King Henry died by drinking chocolate milk. So 1, 2, 1, 2. So my wavelength is actually, oops, that's ugly. My wavelength is 0.129 meters. My energy is what I'm trying to find based on these two things I have for my problem. We only have two variables or two symbols, but one of our equations is actually capital E equals hc divided by the wavelength. H and C are numbers you're going to have anyway, so those are constants. You're going to have them. So H is 6.626 times 10 to the negative 34. Multiply that by C, 3.00 times 10 to the 8. Divided by your wavelength, 0.129. So I'm going to do my math really quick. Give me 1 second, guys. 6.626 times 10 to the negative 34 times 3 times 10 to the 8 divided by 0.129. I do my math, I end up with, this is the number I get on the calculator, just bear with me, 1.54093.02323. And I have a little capital E looking thing and negative 24. So this, remember, so we know this symbol right here, the E and the number means times 10 to the negative 24. So I have how many sig figs? I got 3. Even though I have this 3 and this 4 right here from my constants, do not use those. Use the number given in the problem like this. So 3 sig figs. So 1, 2, 3. I look back here. It's going to stay the same. So 1.54 times 10 to the negative 24. Energy, the unit is joules. So Capital J is the symbol for the unit. So then box that in. All right, so that's it for now for problem solving. We're going to work on this in class. So if you have any questions, let me know then. But if not, I will just see you then, and hit that like and subscribe.